Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hafiza bint Abdul Halim and I'm from course Food Security, University Malaysia Kelantan. Today I will make a video how to solve Mr. Robert problem. Let's start. Okay, firstly is the stage 0. Stage 0 is a problem. Okay, the problem is you like cactus and planning to buy 900 new pots to grow them. While browsing for pots, you saw one internet advertisement claim Mr. Robert invented amazing pot. Give my pot 1 month and your Malaysia grown cactus is better. So the decision is, will you buy 900 pieces of amazing pot or just use normal pot? There are 4 methods. Method 1, 2, 3 and 4. But in this stage, I choose method 4. That is, I do statistical analysis, compare height of cactus after 1 month. This is because we can get the exact result that for the cactus. And also they have population, sample, parameter, statistic, variable and data. The population is 32,400 Malaysia cactus grow on amazing pot. Sample 20 cactus grow using amazing pot. Parameter 32,046 400 Malaysia cactus height after 1 month grow an amazing pot. Statistic 20 Malaysia cactus height after 1 month grow on amazing pot. Variable, the height of cactus use amazing pot in 1 month, and the data is the height of cactus. For the stage 1, that is collect sample data. They have total number, population of sample, total cost hours, and which one that I will choose. From this data, I conclude to choose 20 cactus, the sample, and total cost hour just only 160 ringgit. Total cost hours only 300 hours, and this is because it's very suitable and reasonable. The experiment is you bought 20 pieces normal pot plus 2 pieces amazing pot. Grow the cactus to confirm that amazing pot really great. This is the result that I get after 1 month. Normal pot, which the height or we'll call control group. And also this is for after 1 month amazing pot, cactus height in centimeter, but in amazing pot we call it treatment group. Okay, now this is for stage 2, organized data. This is all the data that we get. First is normal pot, then second is amazing pot. This I have already arranged according ascending order. And now we will continue with stage 3. Stage 3 is present data. They have ungrouped data, group data, and also group data. For ungrouped data, they have record the data from normal pot and also amazing pot. This is the height that have we arranged according ascending order, and this is the total of the height, that is centimeter, and this is also the height for Y. This is the stem leaf design that easily and help we to easy get the data. Okay, next we continue with group data. These two group data for amazing pot. Okay, we just fill this, and also we have to use bar chart. For this bar chart, the diameter centimeter is followed by the height, and also the frequency followed by the frequency. Just make it. Okay, and this is amazing pot and group. This is also group data, but in this we use histogram. For histogram, the diameter we use the midpoint to get, and also the frequency we just use as usual, that is frequency that we get. Now we proceed to the stage 4, analysis data, the measure of central tendency. This is ungrouped data. That is formula. They have mean, median, mode, quarter 1, 2, 3, range, interquarter range, variance, subdivision, coefficient of variation, and also screwiness. Okay, there we just managed to get ungroup data because the limited space. First is this part is normal part. That's because control group. The mean that I get from normal part is 5.5, median 10.5, mode 5.4, and also 6.3. This is we get 2 because they have two data that have highest value the same. Quarter 1, 2 and 3, 6.3, 5.4 and 5.0. The range. The range, how we get range is the highest data minus the lowest data. Interquarter range, quarter 3 minus quarter 1, we get 1.0. The variance, we just follow this formula and we get 0.697. Standard deviation, just square root the number or the value of variance that we get 0.835. The coefficient of variation, the formula is S over X multiplied by 100. S we can get from standard deviation, and this is the symbol for the mean. We just put the data and we can get 50.045%. Okay, this is for the screwiness. The formula is mean minus mode over standard deviation. We get negative 0.898. When we get negative, that means the screwiness is shift to the right. And if we get the positive, the screwiness shift to the left. And if equal to 0, we can the natural. Okay, now ungroup data for amazing part, that is Raymond group. The mean that I get is 6.0, median 10.5, mode 5.2, quarter 1 5.15, quarter 2 5.95, quarter 3 7.75. The range after minus we can get 4.6. The itu quarter range, quarter 3 minus quarter 1 is 2.6. The variance is 1.497. Standard deviation after square root get 1.224. The coefficient of variation S over Y multiplied by 100, we can get 20.4%. The screwiness is 0.6.0 minus 5.2 divide by 1.224, we can get 0.65. When we get 0.65, that means the screwiness is to the positive and it will shift to the left. This is stage 5, that is the last stage, interpret data. Inferential statistics stage 5. Conclusion about 32,046 for 100 population data using 20 sample data. They have null hypothesis and also alternative hypothesis. Just in null hypothesis, the mean population 32,046 for 100 characters high of normal part and amazing part are the same. The alternate hypothesis, the characters high of normal point and amazing point are different. So this is the p value less than equal to 0.05. It is sufficient evidence to reject null hypothesis. P value more than 0.05. Insufficient evidence to reject null hypothesis. So what we get is 0.144. That is more than 0.05. That means null hypothesis is reject, and we just use alternative hypothesis. There is insufficient evidence to reject the null hypothesis. Decision, since statistic test must likely mean height of normal part and amazing part the same. What I need to buy amazing part, that is just waste money. I will just buy normal part to grow up my 900 characters. That means I just choose normal part because that is really reasonable and also affordable. That's all. Okay, that's all from me. Thank you for watching.